Once again, I have a tongue tie. I have issues pronouncing common words. It feels like I'm eating glass. If you think that makes me less intelligent, keep scrolling or get the heck off my page. This isn't for you. With that being said, I want to go over and break down how dangerous is a moon reactor really, okay? So just because a nuclear reactor is off Earth doesn't mean it's off of our list of problems. And I want to break that down for people who actually want to learn. And again, I always suggest do your research. Google is free. You can usually pull up a lot of Science Direct articles too by people with PhDs who have written similar articles on this similar thing. I always encourage you to do your own research. So, I've seen this in my comments a lot. Well, if something goes wrong, at least it's not here on Earth, right? Yeah, okay, but let's actually break that down to what that means. So the first part is the moon environment does not equal safe zone for us. The moon isn't some safe, disposable site, you guys. It's an unstable, low gravity, zero atmosphere hellscape, okay? That makes cooling, shielding, and containment way harder than down here on Earth. So no atmosphere equals no convection. That means no natural way to move heat around or cool things down. The moon's surface goes from plus 250 degrees Fahrenheit during the day to like negative 280 Fahrenheit at night. That's a 500 plus degree swing every 2 weeks. So every 2 weeks. Metal expands, it contracts, and it fractures under that kind of stress. And yes, that includes the precious reactor casings that they're trying to use. So the second part is, what if it malfunctions? So what actually is going to happen if it malfunctions? Let's say a valve sticks, a pipe cracks, the radiator system breaks, the cooling fluid leaks, even a tiny design flaw could lead to a runaway reaction or uncontrolled heat buildup. And if it explodes on launch, which is more than likely right now, which has happened with other spacecrafts, you can look it up, now you've basically just aerolized radioactive materials across the atmosphere before it even gets to space, and it's going to be raining down on all of us. That's the most reality that's probably going to happen. So section 3 is, what about the moon's surface though? Okay, say it does make it to the moon. What if it melts down there? There's no gravity that's strong enough to contain fallout in a localized area there. There's no atmosphere that can slow it down like it does here on Earth. Radiation won't just stay put. Over time, it breaks down nearby materials, kicks up ionized dust, and contaminates any surface or tool that comes near it. Okay? And guess what? The moon also doesn't have a hazmat cleanup crew, and so any future explorations will be literally radioactive coming back. They're going to be bringing that back on their missions, and that's part of the issue. So section 4 of this video is why this still affects Earth. So if you think it's not our problem, I have some bad news. Satellites and astronauts pass through that region, granted. So, if contaminated dust gets distributed by future missions that gets kicked into space where it can end up trapped in orbit around Earth or eventually re-enter Earth's atmosphere, you can kind of see how that's going to be a big issue. Plus, nuclear material doesn't stop being dangerous just because it's far away. That's not how radiation works. Trust me, I wish it did. So, I'm not saying never use nuclear tech in space, but this isn't a solved problem. It's experimental, very high risk with a lot of human being lives on as that risk, us here on Earth, and happening fast without the oversight we need. So if you wouldn't launch a ticking reactor on a school bus full of children, maybe don't launch one into orbit over the planet we can live on. You know? You'd think that'd be common sense, but unfortunately it seems like it's not.